students, how are you all? Hope you have written your exams well. So successfully you completed your semester 1, right? And now this is the time to begin semester 2, and in semester 2 we have 3 units, students. Solid state solutions and colloids and adsorption. Okay, so to begin with, in this class we are going to start the first unit, that is solid state. Okay, so with all fresh new beginnings, with a fresh new face. I mean, I am not new, you are also not new, but with a new semester we are beginning. So just take a new page and put the heading, students, solid state. Okay, so do you remember the units which we have learned the last semester? Gaseous state, liquid state, and also quantum mechanics. Okay, so gaseous state is done, liquid state is done. Now this semester we have solid state. Okay, so if I ask you the question, do you know something about the molecules of a solid? Yes, ma'am, you will tell me so many points. So for your information, I have written few points on the board. So the first and the foremost point that we know about the molecules of a solid, they are closely packed. That means they are close to one another, like thick and close friends, right? So because of that they are held together. So why they are held together means there exist strong intermolecular forces of attraction. So because of these strong intermolecular forces of attraction, their movement is difficult. Therefore we say that they cannot move freely. We also know that they have definite shape, definite volume, they are rigid, they are hard, they cannot be compressed, which we say that they are incompressible, right? And also students, coming to the density, they have high density. Why they have high density? So I have mentioned the reason here, because the molecules are closely packed. What happens? The volume gets decreased. Okay, so density and volume, they are inversely proportional. So volume is becoming less means density will become more. That's why they have high density, leading as molecules are closely packed, there will be a decrease in volume. Okay, and also students, do you know the solids are broadly divided into 2 types. What are they? Do you have any information? Yeah, for your information I am telling you, they are divided into 2 types. They are crystalline solids and the second one is amorphous solids. Okay, so put the side heading, classification of solids. So students, put the side heading, first one, crystalline solids. So what do we learn under this crystalline solids? Okay, so in a crystalline solid, students, the molecules will be having a definite geometry. What is the meaning of definite geometry? That means the molecules, they are arranged, or we can say that they have orderly arrangement. Okay, so in a crystal, or if we take a crystal into consideration, in a crystalline solid we find that they have definite and regular geometry. Why? What is the reason for this? Because of the orderly arrangement of the molecules or ions or atoms throughout the entire crystal structure, students. Okay, so throughout the structure we can find this orderly arrangement, because of which the crystalline solid is acquiring a definite and regular geometry. And also when these crystalline solids we talk about or we learn about, we say that we mention that they are occupying, or the molecules, they are arranged in a 3-dimensional space. Okay, and because of this definite geometry, students, they possess sharp melting points, and also they have anisotropic behavior. In liquid state we have learned about this anisotropic character, students. What is meant by anisotropy? That is different physical properties in different directions. Okay, and also students, these crystalline solids, they possess different faces. Okay, and the angle between any two faces we call it as interfacial angle. Look here, I have drawn three crystal structures. In all these three crystals, how many faces we can find? 6 faces. But the external size and shape is different, right? So, such crystals of the same substance, even though the external size and shape is different, this interfacial angle remains constant. Okay? So, in spite of different sizes and shapes of the crystals of the same substance, interfacial angle remains the same, or it remains the constant. Okay, students, that point you can include here. Even though the external size and shape of the crystals of the same substance, they are different, the interfacial angle remains constant. Okay, so what is this interfacial angle? The angle between any two faces in a crystal is called as interfacial angle. Okay, students, clear? These are all the points under crystalline solids. So second one is amorphous solids. Now, what is the difference between crystalline solids and amorphous solids? Students, you know there are few solids like some plastics, few plastics, glass, rubber and all. If we observe their properties, to some extent, students, they exhibit incompressibility, rigidity, etc. but not to the complete level. Okay, and also if we observe the arrangement of the molecules in these solids, they are arranged in an irregular pattern. That means we say that they do not possess a definite geometry. That means they do not have definite geometrical forms. Okay, crystalline solids we have seen they have a regular arrangement of molecules or atoms or ions by which they get a definite geometry. But here in the case of amorphous solids, because of the irregular pattern or irregular arrangement of the molecules, they do not possess definite geometrical forms. So as they are not having definite geometry, we say that they do not have sharp melting points. And also students, they differ from crystalline solids, and mostly they resemble liquids like in showing properties like electrical conductivity and also thermal conductivity. So they are resembling liquids means their physical properties will be same in all the directions, by which we say that an amorphous solid is isotropic. Okay, hence they are also called as pseudo solids. So when you are asked classification of solids, you should be able to write that they are classified into two types: crystalline solids, amorphous solids. There they have a definite geometry. Here they do not have definite geometry. There, because of the orderly arrangement of the molecules, here the irregular arrangement of the molecules. There they possess sharp melting points. Here they do not possess sharp melting points. There they are anisotropic. Here they are isotropic. Okay students, draw a line till here. So this is all about the introduction and classification of solids. Next, put the side heading students. Symmetry in crystals, laws of crystallography. What is that? Symmetry in crystals, laws, L-A-W-S, laws of crystallography. Okay, so under this we learn 3 laws students. First law and second law might be asked as short answer questions like 1 mark or 2 marks question, but third one is the most important question which can be asked as an essay question. Okay, first put the side heading first law, that is law of constancy of interfacial angles. Law of constancy of interfacial angle. Okay, so this we have learned under crystalline solids. Please kindly write down once again the angle between any two faces. The angle between any two faces in a crystal is called as interfacial angle. Interfacial angle. Full stop. In spite of in spite of different sizes and shapes of different sizes and shapes of crystals of the same substance, comma, the interfacial angle remains constant. The interfacial angle remains constant. Full stop. Okay. So this is about the first law. Okay. Put the second side heading, students. Second law of crystallography. Law of rationality of indices. Spelling RATIONALITY. Law of rationality of indices. Okay. So students, first write the statement of this law. Later I will give the diagrammatic representation and explain to you. Ready? Okay. This law states that inverted commas, the intercepts of INTERCEPTS, the intercepts of any face of a crystal, along the crystallographic axis are equal to simple whole number multiples of intercepts of unit plane. Students, once again I will read out for you. The intercepts of any face of a crystal. Underline this one. The intercepts of any face of a crystal along crystallographic axis. AXES, students, not axis. Okay. Axis are equal to simple whole number multiples of intercepts of unit plane. Okay. Looking little complicated, right? But I will make it easy. No worries. Written the statement. Ready for the explanation? Okay. So students, take a pencil scale eraser and draw this diagram under the statement, students. Okay. So can you see X, Y, Z axis? Okay. Mark the origin point as O. So X axis, Y axis, Z axis, students. Okay. So we are learning about crystalline solids. Hence they are three-dimensional. Hence we show all the three axes X, Y, Z. Drawn. Next. Draw this ABC. This is called as unit plane, students. Unit plane. Next, taking a single face of a crystal and we named it as KLM. Mark it with the dotted lines. Okay, KLM, and students, this distance A, this distance B, and this distance is C. Have you drawn the diagram? Okay. So now students, this OX, OY and OZ are called as the crystallographic axis. Fine. Now, and this ABC is called as unit plane. Below the diagram, write down. Let OX, OY, OZ be the crystallographic axis. ABC, the unit plane. Okay, and you should know what an intercept is, right students? Look here, the distance at which the plane is cutting the axis. Okay, so this much, this is the distance at which the unit plane is cutting along x-axis, and that distance we marked it as B. And along z-axis, unit plane is cutting till here. So this distance we marked it as A, and along y-axis, unit plane is cutting here. So this distance we marked it as C. Okay. So the distance at which the plane cuts the axis, that we call it as the intercept. So the intercepts of unit plane A, B and C. Okay students, so from the intercepts of the unit plane, we can calculate the intercepts of any face of a crystal. Here we have taken one face of the crystal and named it as KLM. Okay, now KLM intercepts can be calculated from the intercepts of unit plane. Okay, so what are the intercepts of unit plane? A, B, C, small letters A, B, C. Okay, so go back and check the statement given by the second law. What is that statement, students? Once again I will read out for you. The intercepts of any face of a crystal can be calculated or can be determined or are equal to simple whole number multiples of intercepts of unit plane. Now you understood the intercepts of unit plane. Now, what are these simple whole number multiples? What is the meaning of that? Whole number multiplied by intercept. That's it. Okay. So, we have intercepts, right? For example, students, imagine a graph sheet. Okay. So, suppose here along z-axis, this is 1 unit, 2 units. Don't mark in your notebook. This is 3. Okay. Now, simple whole number multiple. So, the intercept of KLM along z-axis will be equal to 3 into intercept of unit plane. It is equal to 3. Understood? Now, along x-axis. For example, 1, 2, 3, 4. So, here if it is cutting, 4, simple whole number, 4 into B, that is 4B. Got it? Now, along y-axis, 1, 2, 3. So, 3 into C, it is equal to 3C. So, 3A, 4B and 3C are the intercepts of KLM. Okay? So, just for your understanding sake, I have written these, students. Fine. So, don't mark these lines also in your answer sheet. Got it? Understood now? Okay. So, A, B, C are the intercepts of unit plane, students. And KLM, the intercepts of any face of a crystal, we can get from the intercepts of unit plane. How? Simple whole number multiples. So, the distance at which the plane or the face is cutting the axis, that distance multiplied by the intercept of unit plane gives us the intercepts of any face of a crystal. Okay. So, below the graph, below the diagram, write down, let ABC be the unit plane, small letters ABC, intercepts of unit plane, KLM, face of the crystal, OX, OY, OZ, crystallographic axis, and the intercepts of KLM are equal to simple whole number multiples of intercepts of unit plane, brackets mention small letters A, B, C. That's it. Is it easy? Understood? Very good. So, draw a line till here. Let's move on to the third law. So, students, next one, third one is law of symmetry. Law of symmetry. Written? Okay. Underline the side heading. So, students, under this you can write crystals of the same substance possess similar elements of symmetry. What is that? Crystals of the same substance, they have similar elements of symmetry. Okay. Now, this symmetry in crystals might be with respect to a plane or a point or a line or axis. Okay. So that means we call them as plane of symmetry, axis of symmetry, and point of symmetry. Okay. So symmetry in a crystal might be with respect to a point or a plane or a line. Okay, and students, in this chapter mostly we will be learning about cubic crystals, and the cubic crystals possess total 23 elements of symmetry. So what are those 23 elements of symmetry? I have mentioned here. Kindly write down. Planes of symmetry 9, and axis of symmetry 13. Point or center of symmetry, that is 1. So if we add all this, we get 23 elements of symmetry. Okay. So planes of symmetry, axis, AX, ES, students. Plural we call it as axis. Singular we call it as axis. Okay. Axis of symmetry how many? 13. Center or point of symmetry 1. So total 23 elements of symmetry. Okay. So this is the general introduction about law of symmetry, students. We are going to learn these planes of symmetry, axis of symmetry, and also center of symmetry in detail. Okay. And this is the very important question, students. So we can expect any one question from these 3 in your exam. Fine. So total we have same laws of crystallography 3. 1, law of constancy of interfacial angle. Second one, law of rationality of indices. Third one, law of symmetry. So we have not completed this one, students. So in the next class we will be learning all these 3 in detail. Okay, students. So see you in the next class. Take care. Bye-bye.